My name is Brian Kraft, and this is my CSC 480 assignment 2, the Simacogo game. So the first method we have is just going to make a move. It's going to take the game board and it's going to return the new state based on where you want to move the piece. I know we didn't have to include the row, but I just did based on how I coded the game. The get score method is going to go through each piece in the board and basically try and find the pieces next to it or on the diagonals or above or below and see if the score needs to be incremented. And at the end we return the score, but we divide by 2 so we're not double counting. The get moves is our successor function. It basically looks through each column on the board and sees if a piece can be dropped. And then for alpha beta pruning, we call it recursively at a depth of -1, and so once we get to a depth of 0, it means we're at the deepest part we want to go. We start returning the score, and that percolates up through the recursive function, and then we basically continually take the max, and that ends up being our alpha, right? So this guy's maximizing here, and then down here we minimize, so we're just using beta. And then we just prune right here if beta is less than or equal to alpha. So by recursively calling that, it's going to percolate up the tree, and then eventually we'll get a cost for the possible moves that the AI can make. And then if we go down here, we'll see that to initialize the game, it just makes a board with a bunch of stars to show that those are open moves. And then you have the mover and the depth and the limit, and those are just used in the alpha beta pruning. And then to actually play the game, we just make sure that the board isn't full, and if it is, we return a final score. If it's a human, we get the possible moves using the successor function, and the user just inputs a move to make. Otherwise, if it's the AI, we just look at the alpha beta pruning function, and then we go through the moves and we pick the max move. So we get the best move after we call the alpha beta pruning, because the alpha beta pruning returns a cost for all the possible moves for that AI. And so if we just call that play game method, we'll just apply a 5, should work just fine. We'll just do a few moves. I'm going to make a move on the third column, or technically fourth, since Python index is at 0. And as you'll see, the AI want to block me, so I'll go try and drop a piece on him and block him, and now he's going to block me again. So maybe I'll block him on the left, and so it looks like the AI takes the diagonal points right here. So as you can see, it's kind of blocking and beginning to try and consolidate territory. So I'm going to upload the code on GitHub, and if there's any other questions, you can look there.